Hey folks, Dr. G here. I'm just doing a little demonstration on how to use a publicly available data set. This is melting point data from Kaggle, ChatGPT, and also Jupyter Notebooks, or really Google Colab through your Google Drive account to do some analysis and plotting of chemical data using Python. So if we look at this data set here, this is melting point data. So there's all sorts of chemical descriptors here. There's the molecular structure using something called a SMILES string. This is a way of storing chemical structures using text. And there's all kinds of data in here. And the idea is that you could take a data set like this and try to predict the melting point of that particular compound. And so this website called Kaggle, they host all sorts of data science contests where they release public data and people can do their best to try and create predictive models using machine learning. Really cool what they're doing. This has been around for quite a while. But what's really great about it is you can just use their data, right? So this data is available. So step one, let's download the data. Download as a zip. And so now that data is right here in my downloads. I'm going to go ahead and open up the archive here. There we go. So we've got Excel files and CSV files. I always recommend working with CSV files for Python. There are libraries that will accommodate Excel files. I just don't think it's worth the trouble. I think CSV is a lot cleaner. It's sort of the format that pandas is expecting, right? So there's a library in Python that's super useful called pandas. It's like Python and data science, I think is what it stands for. Great library, and sort of the easiest way to get data into a pandas data frame, which is the main way of storing data for pandas, is with a CSV file. So I always recommend get the CSV file. Let's see what we've got. They got a data set and good melting point data set. Interesting. Bradley double plus good melting point data set. Melting point data set. Let's look at the size. So that's only 500 kilobytes, and this is almost 5 megabytes. Let's take the big one, right? Let's go all in here. So let's see. I've created a Google Drive folder here, so I'll drag that there just to hang on to it. Let's see, where's the big one? There's the big one. Drag that here. So that so I've got it. There we go. And that's there. Now, just because it's here doesn't mean if I put a Google Colab file here and start doing some analysis, you can connect it to your data set via Google Drive. There's a way to do it. I don't know. I think it's easy enough to just drag your file in every time you're going to do the analysis. It doesn't take all that much. So I don't know. That's how I'm going to do it today. All right, so this is the file I'm going to be using right here. And I've got ChatGPT open here. So let's tell ChatGPT what we want. So let's say, I have a CSV file that I'd like to do some analysis on. The CSV file contains chemical data. Specifically, it has various molecular descriptors and melting points for different compounds. And I'm interested in seeing how these different observables correlate with each other. So I'd like to see some sort of correlation matrix. And I would also like to see, I would also like you to write some Python code to do some linear regression with some of this data. I'd like to see an example of linear regression as well. Yeah, I'd like you to write Python code for doing all of this. I want you to use the pandas library. And in the end, I'd like you to create a downloadable Jupyter notebook that I can use to get me started with this analysis. Thank you. All right, let's see how the voice to text worked. That looks like it did pretty well. And so now I'm going to hit Shift Enter a couple of times, create some space without submitting it. And now I'm going to drag that file in there. Oh, you know what? Let's see. I'm going to add a little statement. I'll be like, here is the CSV file for analysis. There we go. Now I will drag that in. Yep, that's the good one. Put that there. It's loading. There it goes. So I gave it the file. I said what I want. Let's see what it does. It says it's thinking longer for a better answer. Okay, planning analysis in the Jupyter notebook. So I used to just, just let the large language model just rip, just let it rip and it would just, start talking, right? But now they have these sort of chain of thought things going on where they're trying to use logic. Analyzing. I saw an interesting paper not long ago where one of these chain of thought things, they found that it would give you a reasonable chain of thought for whatever solution it came up with. But it turned out that like what the neural net was actually doing and what it said it was doing was completely different. So who knows? Boy, it's really thinking about this one. All right, looks like it's done thinking and it's going to start talking now. Good, it's going to create a correlation matrix for us. I definitely wanted that from matplotlib heatmap. Good, that is the library I would have chosen. Finds the descriptor most correlated by running simple linear regression with NumPy polyfit. Okay, interesting. I've seen previous times where it would use a different library for that. They would use sklearn, which is a machine learning library. But NumPy, has all sorts of stuff like that. And, linear regression has certainly been around for quite some time before people were using the words machine learning. Let's see here. It runs multiple linear regression to get the top K correlated descriptors. Oh, wow. So it's going to find the most strongly ones. So it's going to find the most strongly correlated ones and produce clean scatter. Yeah, that sounds like exactly what we want. All right. Well, it says it made a notebook, and here's the link. So let's click on it and see how it goes. All righty. Go back to my downloads. There it is. All right. See how it's .ipynb. That's a Jupyter notebook. But a Jupyter notebook you can drag into Google Drive and open it as if it were a Google Colab notebook. So it's kind of like how you can put a Microsoft Word document in Google Drive and then just treat it like a Google Doc. So if I drag that in there, drag that in here. All right, so that's loaded into Google Drive now. And if I click on these three dots here and I say open with Google Collaboratory, there we go. Look at this. If you're new to this sort of thing, this is a really nicely formatted Jupyter notebook or Google Colab notebook. So you see this cell right here. So there's different types of cells here. So this is a code cell. This is a cell for running code, and this is what's called a markdown cell, or I think they call it something slightly a text cell. So in a Jupyter notebook, they call it a markdown cell. And this is for making nice looking text. If I double click this, you'll see that there's actually a code for making that look nice. So you notice how there's a single pound sign or hashtag here to make that look like a title. And just like I would execute a code cell, I can execute this text cell by hitting Shift Enter, and then it goes back to that. So if you ever want to see how they made it look nice, double click and you can see what's going on. See a double asterisk on either side, gives you bold font. The numbers, you just write numbers and it knows to format it that way if you do that. So yeah, that's that. Just wanted to kind of point out that not only does it give us some usable code, it gives us a really nice looking Jupyter notebook. So let's see if it works. Actually, wait, there's one more step. We have to make sure that this file is actually accessible to our Jupyter notebook, right? So right now, our Google Colab notebook, if I were to run this, it can't find the data. But if you click on this little folder right here, these are the files that that are either accessible to the Jupyter Notebook or the files that the Jupyter Notebook produces. So you can upload things by just dragging them here, and you can download them by, well, I'll show you how to do that later, but it's not hard. So let's drag that data into here. So I think I left that here. It's inside of this archive. There it is. So this is the data set we wanted, the big one, right? Where is it? There. Yeah, the one that's almost 5 megabytes. So let's drag that right here. It's going to give us a warning and say, oh, you know, I'm not saving this. And we say, that's fine. I have it saved elsewhere. We're just using it for this session. That's totally fine. So we put that there. And so this file name here, right, this Bradley melting point dataset.csv, that is the exact name here, right? So that's important that these match perfectly. So, you know, I encourage you to like carefully read these things and see if they're doing what you think they're doing. But today I'm living dangerously. Let's run the whole thing. Let's say, let's click run all. So this is going to run all the cells in the notebook, and we'll see if it got it right. Okay. Let's see if it produced any errors. Wow, look at that. I see no errors so far. Interesting. So it didn't produce any errors of the sort that, you know, the code doesn't run or something like that, right? It didn't produce that type of error. I don't know if the analysis was done correctly, but it produced for us a working notebook. So let's take a look at what it actually did now. So first, we have to import the libraries we're going to need. We're going to want pandas, numpy, matplotlib, right? The data science one, the numerical operation one, and like numpy is really good with matrices and things like that. And also matplotlib, of course, for doing plots. Let's see, we've got RNG and random default. So this is producing some random numbers for some reason for reproducibility and any randomized steps we might add later. Okay. So I believe this is for like a random seed, maybe. So random number generators aren't truly random. At least the typical ones you see are not. So, but they have something called pseudo random numbers. But sorry, I don't want to get too far off topic. I think it's using a good old 42, right? If you know, you know, as the seed for the random number. Let's see, display max columns. Display width. Okay, so it's setting some options for pandas. Interesting. Let's see what else it's doing. Importing a path. Okay, so it's creating a path. Interesting. You didn't really have to do that. This step isn't really necessary, so it's doing something you don't really have to do. You could have just put this here, but that's fine. I mean, there's nothing wrong with it. And let's see what it did. I mean, it loaded the data correctly. Yeah, so it definitely loaded the data just fine. Interesting, the column do not use because, right? This is sort of like the importance of cleaning data, right? Because, you know, you get these huge data sets. There might be some stuff in there. There might be mistakes. Anyway, and this NaN, not a number, that's if a Python operation is trying to do something mathematical, it doesn't even return a number because of some error. That's kind of how I can explain that briefly. So smile strings, right? This is what I was saying. You can take a molecular structure and express it in terms of plain text. Right? So these are like organic molecules where the connectivity is very important, right? Which atoms share bonds, which do not. Are they single bonds, double bonds? There's an aromatic region, all that sort of stuff. You can actually encode that in just plain old text. So that's what a smile string is. And, you know, I don't think there's a lot of people that look at these things and know what the structure is all that well. Like, you know, you can do it. It's possible, but usually you just use software to translate it either from a structure into a smile or a smile back into a structure. Let's see what else it did. So it's calling the info method, right? So it loaded the data into a data frame called df, and we're looking at the info. So this is df.info. So it's calling the method info. That'll tell you a bit about the data frame. So it's got over 28,000 rows, 9 columns. Yeah, there's got different, the key, the name, the smiles. Great. So this is like sort of the types of data that's available to us. And basic statistics for the numeric columns. Okay, so this is using another one called describe. So this is a built-in method for any data frame that you can call, and it's called describe. And after that, it's going .t, capital T, that means transpose. So, rows become column, column become row, right? That's what transpose is for a matrix. So let's see. So the description here, they're showing us how many, the count, the mean, standard deviation, the min, various statistics here. So this is like, how many melting points do we have? What's the mean melting point? What's the standard deviation on the melting points? Okay, great. So it's giving us some information about the data we loaded. So far, no problems that I can see. All right, so now this cell, this is kind of an interesting cell. So it's going through the columns to figure out which column is the melting point. I think that's what it's doing. Let's see. So keep only the numeric columns. Okay. So they're saying like, there's a way of selecting only the columns that include numerical information, right? If you tried to do linear regression on the smiles strings, those are strings. That'd be kind of goofy, right? You wouldn't do linear regression on a bunch of words. So, so that's what it's doing here. Let's get only the numeric stuff. So I guess it's trying to figure out which ones are numeric as part of what's happening here. Choose a melting point column by name. So this is something that I think this is like kind of a ChatGPT thing that it makes sense on their back end to do this, to kind of be like, all right, which one's a melting point? Because if you notice in my prompt, I didn't tell it which one was melting point. If I look at, let's see, it showed us the head somewhere. There it is. So MPC, me just, knowing what this is, I would say, I bet that means melting point in Celsius, right? That's probably what MPC is, melting point Celsius. But, the computer doesn't know that, and ChatGPT doesn't know that necessarily, right? So right here, it has different hints for which column could be for the melting point. So this is the sort of thing that if you're creating a Jupyter notebook that you're going to be using a bunch or whatever, or a Google Colab notebook, that it's MPC, right? So you don't have to actually do this step. So this would be something that maybe I would cut out. And yeah, we don't actually need that. But I think it's very smart that the developers at ChatGPT have it doing stuff like this on the back end, that it's doing that stuff. So it shared this step with us, and I'm glad it did. I think that's a good thing. But be critical of it and be like, okay, maybe that made sense for them. Does that make sense for me? Do I really need to go through these and figure out which one's the melting point? No, it's MPC. I know what it is. And let's look at the correlation matrix too, and then we'll probably stop there. So here's the correlation matrix. So numeric df. Okay, where did that come from? Let's find that. Numeric df, that's here, right? So here, this is a data frame with only the numerical information, right? Because if you're going to use a function that finds correlations and one of your columns has a bunch of strings in it, a bunch of words, right? That's going to throw it off. That's going to throw an error or something like that. So this was a smart step to be like, give me only, okay, so let's look what it did. So it took the original data frame and it called a method built into data frames called select d types. Select data types, that's what that means. Select data types, and it says to include np.number. So basically something from NumPy. So it's using an attribute of NumPy called number that basically I think it accepts any kind of number, right? Because there could be an integer, it could be a float. Is it a 64-bit float, a 32-bit float, right? There's different ways you can express numbers, but they're all numbers. So I think it's saying basically only grab the numbers. And then notice how it says .copy. So that's an important Python thing too, where the data frame, there can be issues with it's called mutability. I don't want to get too in depth on that, but basically sometimes if you assign something, right, this is the assignment operator, a single equal sign, we're assigning the thing on the right to the thing on the left. Sometimes it'll kind of go both ways, where if you do it the one direction, it'll kind of affect the original thing too. Look it up, it's called mutability. But if you do .copy, that ensures that this data frame is its own data frame, right? We're not doing anything to that original one. This is its own thing. We've made a copy of it. So that's why it uses the method .copy at the end. So that's a good habit to be in as well. So obviously it's going to take up a little more memory, but that's fine, right? We have plenty of memory here to store a brand new data frame called numeric df. So we have that numeric data frame. That's the one we're going to use for the correlations. So that's why we're down here now. And we say core equals numeric df dot core. So look, they're data frames. As data frames are amazing objects in Python, right? They're sort of the star of the pandas library is the data frame. There's so many built-in methods. It's amazing all the different things you can do. And one of them is .core. And look, if I hover that, oh, that's really cool. So if I hover over that, it gives us this description: compute pairwise correlations of columns, excluding NA/null values, right? So if you have those NaNs, it'll ignore those. The methods, oh, interesting. And you can even tell it what type of method to do correlation with. I think Pearson is the default one. That's like the most common. So interesting. Wow, that's cool. So .correlation numeric only equals true. So again, we sort of have like another level of safe to be like, hey, only do this with the numerical values. Okay, cool. So that's what happened here. And so it produced this correlation object. And if you just print out the correlation object, you'll see that. But kind of even better is to do a heat map. So here we're using, let's see, this is from matplotlib, right? See, it has PLT here, right? Back in the beginning, it imported matplotlib.pyplot as PLT, right? So that was to bring in the plotting stuff that we want to do. And so we have plt.figure, fig size 8x6, right? So these are the dimensions of the figure, right? If I want it bigger, I'll just double both of these. Let's go 16 by 12. Right? That's the size of the figure. Right? That's crazy. Let's go back to the original size. Just wanted to show you that. 8x6. Shift enter to execute the cell again. And yeah, so basically it produced this nice looking correlation matrix. And so if we look at it, we see that 1 means perfectly correlated, and -1 would mean anti-correlated typically if it used the Pearson one, which I thought it would. So upon looking at this a little more carefully, it actually makes sense that we're not seeing good correlation here, right? Because a lot of these numbers are just like IDs and stuff, right? We've got, let's go back to it. Here we go. Got the name, smiles, MPC, CS, ID. That's some sort of identification number and a melting point. So really, if I saw a correlation here, that would actually be a little more frightening. Be like, why are these things correlated? So yeah, we're not seeing correlation here because these numbers are not, anything particularly useful for studying that way. But what we can do. So these smile strings, you can use those smile strings to compute all sorts of interesting information, right? So maybe you want to know how many hydrogen bond donors are on a particular molecule, how many hydrogen bond acceptors, what's its molecular weight, all kinds of stuff like that. So I'm going to say, let's go back to ChatGPT and say, I want you to compute some molecular descriptors. Let's go back to ChatGPT and say, that worked great. Thank you very much. But the one thing that I'm realizing is that the data in that data set, it's really about smile strings and ID numbers and things like that. So we actually can't get any interesting correlation from that, of course. So can you next use some sort of Python library to convert those smile strings into some sort of molecule object that can be used to compute all sorts of interesting molecular descriptors, like maybe the number of hydrogen bond donors, the molecular weight, things like that. So what I'd like you to please do now is create a new Jupyter notebook that loads everything just like you did, but then put in an intermediate step where you calculate all these molecular descriptors and put them into a pandas data frame, and then we'll get the correlation matrix from that. All right, thank you very much. Let's see how the voice to text did. Here we go. Yeah, it looks good enough. Let's send it. I find that voice to text for ChatGPT is quite good. And by the way, that's not a large language model, right? The large language model is the thing that takes in text and responds to text. That's a voice to text model, right? So there's lots of different types of machine learning models that ChatGPT is using. But the large language model is kind of the most famous one. That's the thing that really put them on the map. But I've kind of noticed some people start thinking of the whole thing as a large language model, and it's the main component, but it's not the only component. All right, we're getting an answer after about a minute and a half of waiting, something like that. Notebook creation hit a temporary write error. Interesting. So it made mistake as it was creating it. Let's see how it did. Please okay, before I retry, please confirm one thing so I can tailor the code correctly. The name of the smiles column. Okay, interesting. Yeah, no problem. Let's see here. So once you tell me that, okay. Interesting. Okay, so let's tell it. Let's see here. Before I retry, please confirm one thing. What is the name of the smiles column? Well, let's take a look. I think it's just smiles, yeah, in lowercase. So you have to get that right. Make sure you tell it the lowercase or uppercase correctly. The column name you requested is smiles. Let's see how it does now. Is that all it wanted? Once you tell me that? Yeah, that's it. Let's see what it says it's going to do. Load your data set. Good. Convert the smiles into RDKit molecule objects. Yes, that is the library I expect it to use. It computes the descriptors like molecular weight, hydrogen bond donors. Yeah, great. That's the kind of thing I want. Builds a descriptor data frame and shows correlation with melting point. Performs linear. Yeah, this is exactly what I want it to do. So, I didn't say exactly that in my description, but this is certainly what I meant. And so it did a good job of interpreting what I asked for into nice clean steps 1 through 5. So it's interesting. This time it asked me which column is the smiles, right? So maybe it was listening when I was talking about how it had that step of figuring out which one was the melting point column. I'm kidding, but okay, there we go. So here's a new one. Let's just get a new one and start over. Let's see how it goes. So I'll download that. Let's just save this and close it. Save and close. So that was here. I'm just going to drag the new one. Let's see what they called this one. They call it something different. Here's my downloads. Smile. Okay, good. It gave it a different name, so I don't have to change the name. Drag that in there into my Google Drive account and 3 dots. Where is it? Open with. Sorry, it's early. There we go. All right. So here's a new one. And just like before, let's just go for it and hit run all and see how it does. Oh, I forgot to load the file. Whoopsies. This is going to throw an error. Yeah. So let me click the folder and we'll drag our data in again. Can't forget to do that. So it was the big one. That's this one. Yeah. Drag that in there. Gives us that same warning. We don't care. Wait for it to show up. This is a little refresh button. Now you can hit the refresh. It's still loading, I think. By the way, one thing I've noticed is if you have more than one Google Colab open, understandably, the folks at Google are like, hey, you're abusing our servers. Close some of these things. So I closed the other one. So that's not the issue here. I don't know what this is doing. It's taking a while. There we go. Oh, it's finally there. It's loaded. Okay, let's try this again. So now that it has the data set there, and let's see, it loads it here. Yeah, So this time it doesn't use that path. Remember before it had like it used a function called path. Here it's just defining it as a string, which is what I thought it should have done in the first place. So let's run it. Click run all and see how it does. How does it do this time? Okay. So no module named RDKit. Okay. So what this means, when a Google Colab fires up, there's certain libraries that are already installed. Things like pandas, NumPy, the super common ones. RDKit is not as commonly used. So what we're going to want to do is we're going to put a new cell and we're going to have an exclamation point and say pip install RDKit. But for a moment, I'm going to pretend I didn't know that because I want this to be a tutorial of how to use ChatGPT to help you with this. So I'm going to copy this. Let's do that. Oh, look, if your import is failing due to a missing package, you can manually install dependencies using either pip or apt. Okay, cool. So it gives us that hint as well, but let's pretend I didn't know that. So let's go here and let's go here. Let's say, looks like RDKit is not installed for Colab. Here is the error. You can easily fix that with this. Yeah, this is exactly what we have. So let's see. I'm going to use this one. This is the one I would normally use. So copy that. Probably doesn't matter which one I pick, but I'll use that one. Okay, so now we're going to use that trick I showed you earlier, where if I click in the cell and then I click to the left of it and the letter A, now we get a cell above. I paste that. This exclamation point, that means you're running this cell like it was like more like a terminal. So I'll run that. So now we're installing RDKit. Installing successful. Great. So so this is really cool that Google Colab lets you do this, right? You actually you can install libraries that it doesn't have by default. That's really neat. So okay, let's click run all and see how it does this time. Oh, it's doing that. Requirement already satisfied, so it's kind of flying through this step because it's already in there. All right, we no longer have an error here, so that fixed that. Loaded the CSV files successfully. Converted the smile strings to RDKit molecules. Okay, so we're getting some errors here. Really warnings, not errors. Can't Kaggleize mol. So a Kaggle structure is a way of writing a molecular structure. And so basically it's saying some of these smile strings are a little funky. I can't make a molecule object out of that. So, in my instruction, we talked about objects a little bit. At some point, I'll put a video like sort of about some sort of Python basics you should know for this sort of thing. But for now, just think, an object is a programming construct, something that for your code. But basically, it has to create, if it wants to calculate these different values, and look, it worked. It create number of hydrogen bond acceptors, number of hydrogen bond donors, number of rotatable bonds, right? These are all molecular descriptors. And in order to get that, it had to convert the smile strings into a molecule object. So basically that it translates that text into something with real molecular details, right? It knows which atoms share a bond. It knows if they're single bonds, double bonds, etc. Looks like we've got an error down there somewhere, but we'll get to it when we get to it. Now, compute molecular descriptors. Okay, so this was the step where it created the molecule objects. And then it said, all right, these are the descriptors we want to do. Molecular weight, number of hydrogen bond acceptors and donors, etc. Compute the descriptors. If mol is none, okay, return NaN. Remember we talked about not a number? So this is just being safe. It's basically in this step where it's trying to create molecule objects from the smile strings is a big data set. I think it's almost 30,000 rows or something like that. I forget how many. So, odds are some of these are, a little off, right? You can't assume that every data set you get is totally clean, right? Oh, look, it tells us how many. Oh, that's neat. So the number of valid molecules was 28,344 out of 28,645. So pretty good. Most of these molecules were just fine. So yeah, we have over 28,000 molecules in our data set, just like that. Okay, so here's our descriptors. Okay, so this is this is the curly braces tell us this is a dictionary with keys and values. So in this case, the keys are the names of some of the functions we want to use, and the way you calculate them is from the descriptors library. So RDKit has something called descriptors, and that's been loaded in the session earlier. So it has these descriptors. Okay, look, and it worked. So the data frame is saying take the molecule object and apply the compute descriptors function. So that's, yeah, this function, applied compute descriptor. There it is. Apply the compute descriptors function right here, right? And so this loops over the descriptor functions, right? And it applies each one to the molecule object. Yeah, this is really nice code. So let's see. Yeah, and that worked. So it produced our data frame of molecular descriptors. So now we want to combine the data frame with the descriptors to the ones with the melting point. I have a suspicion here that it has an error here that maybe the melting... Oh, that's funny. We're back to trying to identify the melting point column automatically. Please select target column manually. How about that? That is wild. Okay. How about that? Okay, so so it says to do it manually. That's fine. How about that? Okay, so we know how to do that. It was MPC, right? If we look at the original, where is it? If we look at our original data frame, MPC, little m, little p, big C. All right. So let's do that. Where can I? Okay, descriptor df, and then, yeah, this is it. Target column, find melting point column. Yeah, that's the one. So it's trying to figure out the melting point column. So I could just change this. So this is just going to be melting point Celsius. There we go. Now I'll rerun this cell by hitting Shift Enter. Now what's wrong? Oh. Let's just skip this step now. So what I'm going to do, I'm going to, yeah, we don't need any of this. I'm going to highlight all of this. Unless it uses that target column later. Oh, it does. Okay, I'll just do it this way. I'll change. Okay, so I'm gonna hit Command Z to undo. So we'll leave that named as target column. I'll change it here. So target column equals, and then I'll just do MPC. And notice I put it in quotes because that needs to be a string. So let's run that. Shift Enter. Hey, now we're good. Okay, cool. So now this works. So now let's keep going. Shift Enter, Shift Enter, Shift Enter, and we got a heat map. Check it out. This is really cool. All right. So again, we see perfect correlation with itself, right? That should be correlated 1. So that's kind of a good quick sanity check to make sure it's doing something reasonable. And perfectly anti-correlated would be -1. And it does get a little negative this time, right? Here's -0.2 in our legend over here to show us the values. So the most anti-correlated is number of hydrogen bond donors and mole log P. Mole log P and number of hydrogen bond donors. This has something to do with like solubility. So you could look that up. That's anti-correlated with number of hydrogen bond donors. Something with a strong positive correlation up here. The molecular weight is strongly positively correlated with the heavy atom count. All right, well, that's not surprising at all, right? If you've got a lot of heavy atoms, it's going to make your molecular weight heavier, more typically. So nothing surprising there. This is a strong anti-correlation too. Mole log P and, oh, okay, that's just it's the symmetry of it. So anyway, this is our heat map to show correlation. So hopefully this video is helpful in showing you, how you can use ChatGPT to move very quickly with doing analysis of chemical data sets. And we started with a publicly available one from Kaggle, got ChatGPT to write our Jupyter notebooks, And it just didn't just, work out of the gate the way we wanted it to. We had to kind of be intelligent about it, ask for some corrections from ChatGPT, and even, tweak things by hand a little bit when things went sideways on us. So, all right, I hope this was helpful. I'm Dr. G. Thanks for watching the video, and I'll see you in the next one.